Welcome to the Selecting Materials and Applications for SLS 3D Printing. My name is Chris. I work for Formlabs. I've been in industry for going on about 7 years in total. During my time at Formlabs, I've worked a wide variety of opportunities. So that means new customers, current customers trying to expand their fleet, and that's both on the SLA and SLS side. So I've seen a wide variety of customer needs and geometries and part requests. Also, in my day-to-day work, I oversee the SLS custom print farm. So if there are any current customers on the call now, at least in the US, most likely I've had some effect or control over your custom sample, which is always great to say. As I go through the next 20-30 minutes of talking, obviously questions and chats and more polls will pop up. Just familiarize yourself with the features available on the site here. Obviously, Q&A questions will be answered at the end. General chat, just hellos, will go there. Obviously, want to make sure we can address any questions that pop up, any needs that you all need to be addressed and answered. So for the very new attendees that are not familiar with Formlabs, Formlabs is obviously a 3D printing company. We are a vertically integrated 3D printing company that was started back in 2012, 2011 out of the MIT Media Lab. Since then, we've grown into a major player in the additive space. We produce both SLA, stereolithography, or resin printers, as well as SLS or selective laser sintering printers. We do the full engineering top to bottom in our headquarters in Boston. We develop our own resins, and all of the servicing and control is done basically under one roof. As some customers have known, we do not produce a ton of individual SKUs or products. We go very, very deep into very few amounts of products. So we know that each product that we are releasing is going to be exactly how we want it. How we differentiate ourselves from competitors, we are sort of the quintessential professional level printer at the lowest cost possible. We want to enable as many users as possible to do whatever they want without the extra headache of fine-tuning print settings every single time or trying to reformulate their own materials. We do all the heavy lifting. Your job is to just have the applications, have the needs, press go on the printer, and the printer does the rest. On the bottom right as well, you can see the full ecosystem. So it's not just printers, but it's also going to be washing and curing parts or sifting parts, recovering powder, and cleaning them off. Today's highlight is going to be obviously the fuse or the SLS ecosystems. So just a little bit of a timeline of where we've been and obviously where we're going now for the future. The Fuse 1 and the Fuse Sift were the original sort of ecosystem that we officially announced and released back in 2021. That is utilizing a 10-watt laser. The following year after, we introduced the Fuse 1 Plus 30 watt. The difference in the wattage will allow us to both go faster, less dwell time for certain materials, and it unlocks the ability to run certain materials with the upgraded hardware. And we also have a inert nitrogen gas hookup, basically creates a cleaner environment for the printing process. Just helps a lot of our production customers get the same part every single time. And obviously for the rapid prototyping customers, they get parts a lot more quickly. In 2023, we focused a little bit more on the overarching ecosystem, either reducing the total cost. So the Fuse depowdering kit is a little bit more of an agile system to clean off parts that could be used in parallel with a Fuse Sift with a different material. Or if customers were a little bit more constrained on money or space, that Fuse depowdering kit is a little bit more compact, a little bit more manual, so it takes a little bit more time, but it still gets the same outcome, which is you reclaim your parts and are able to fully clean them off. The Fuse Blast has been my favorite product the last couple of years at Formlabs. It is our fully automated media blast cabinet. So what that means is a ton of time saved from the sifting process to your actual end use parts. Everything is done in a two-stage process. You use glass media, compressed air, and then an inline ionizer to discharge those parts. So no static cling, no leftover dust, particulates. Everything is ready to go at the very, very end. So it takes about 15 minutes. We did the math last year. It saved me probably 500 hours of time when it comes to the comparison to manual media blasting. So we also utilize the blast not just in our systems, but other powder bed fusion systems, and our customers are enjoying the time off. Last item on the right-hand side is a add-on to the Fuse Blast. So I mentioned earlier, the standard Fuse Blast cycle is using glass media and compressed air. What the polishing add-on is doing is adding a little bit of moisture, and we are changing from a glass media to a plastic media. And what that will do is mechanically abrade the parts, basically smooth them out, similar to a almost injection molded like surface finish, or maybe if you've vapor smooth parts in the past as well, just trying to get that super high level of surface smoothness and quality that our customers are obviously expecting. So with the Fuse One Plus at this point, if you took all of the powder bed fusion printers, small format, large format, whatever size you want, put them all into a bucket, and you chose one out at random, about 50% of them that you choose would be the Fuse One Plus. The reason for such a wide and large install base, obviously it's going to be on the cheaper side, more affordable for a lot of customers, but we still have the unmatched reliability, wide range of materials. It's obviously compact, so it can fit in either office space or closet space, depending on your exact needs. And we're also able to produce parts very quickly so that customers can either start with one, and as they build on new materials or build up production, they can very easily scale up production and keep it flexible as whatever applications come up, they can be more agile and keep up with the basis. The sift and the blast, they make up the other 2/3 of the ecosystem. The Fuse One is obviously going to be producing your parts, but those parts still need to get cleaned. You need to recycle your powder, and you need to fully clean your parts. I think this is where we have most of our differentiators between similarly priced systems, in that, yes, the printer, it produces great parts, it's fast, but most of the headaches that customers experience come from the post-processing stations, either getting powder everywhere or having to manually clean off every single part. With the sift and the blast, customers see none of that. You'll see the build chamber on the sort of middle left section of the sift. It'll raise up your build and powder into the sift area. There's negative pressure. There's a glove box where you can stick your arms through, so everything is perfectly insulated. You'll use various brush tools and cleaning devices to get off most of the powder. It doesn't have to be perfect. The extra step that we always want to highlight is going to be the mixing of powder. So with the Fuse and SLS in general, we can't use the same powder over and over again. We need to refresh with new powder. And what the sift is doing is taking basically 2 storage bins of used powder that gets built up as you clean parts, and new powder that you fill in. It will automatically dose it at a set rate into the powder cartridge, that little blue tab you see on the bottom. That will then get moved back into the printer, and there's really no chance or opportunity for powder spillage. So that makes a workspace a lot more clean, and it's a very hands-off approach. You're just grabbing that powder cartridge, turning it upside down, and then putting that back into the fuse hopper. The blast, I went into detail a bit earlier, but again, it's a automated system. You can also do a manual mode as well. If you have either very large parts or small and intricate pieces, you have full control over the pressures, over the time, over the tumbler speed. And just like everything else, there are built-in maintenance tasks based on either number of print hours, hours of blasting, whatever it is. And then there are built-in step-by-step instructions on how to complete those maintenance tests, or it'll be a QR code or something similar to send you to a full page online so you can follow those steps and ensure that your ecosystem is up to date with all of the maintenance tasks and things like that. Obviously, anything larger than that, like heaters or whatever, that's all covered under standard warranty and service packages. So one more time, from STL file or .prt to your end parts. Preparation is done in Preform. Preform you can download off of our website now. It's free. It is the main medium, taking your step files, mesh files, and turning them into something that the printer can read and then obviously print. With SLS, you are going to be nesting your parts in a 3D space, and we do have built-in packing algorithms to optimize the pack densities and utilization of material. So there is basically a one-click print where it will nest them, send it to the appropriate printer, and if your printer is primed, it will start right away. Setup on the fuse printer is pretty straightforward. It's going to ask you, is there powder? Do you have a build chamber? Are your optical lenses clean? If they aren't, you'll hit a begin button. It takes all of 5 minutes to clean those optical windows, and then you're ready to go. You can keep it primed and have it run automatically, or you can upload your jobs beforehand, then clean it, get it ready to go, and then press print. It's completely up to you. The printing process, there will be a printing stage and then a cool down stage. Printing is anywhere from, say, 12 to 18 hours for a full build. That build is preheating the powder to just under its melting temperature, so roughly 180 degrees Celsius for nylon 12. So what that means is it will need to gradually cool down afterwards, anywhere from probably 12 to 14 hours for a full build. So what some customers will do or utilize is a second build chamber. So while one build chamber is printing, the other build chamber will be cooling in the sift. So by the time the hot build chamber is cooled, you'll have another build chamber to remove from the printer and swap them out. So your utilization rate of the printer is quite high. Depowdering, that is the fuse sift. You can see some of the brushes and roughly how much powder you want to remove. Most customers, most geometries, you can get 80%, 90% of the powder off in just a few minutes. That last 20, 10% will be removed in the blast via that automated process or the manual process as needed. Okay, let's focus on materials. Formlabs has a wide variety of materials you can see broken down by standard nylon, some nylon composites, and TPU. I will say most customers will be drawn towards and stick with the nylon 12. The reason for that is it is a very recognizable material, either more traditional injection molded versions of it, or just, people know what nylon 12 is. Basically, every SLS OEM has their version of a nylon 12. Super easy to print with. It's biocompatible, sterilizable, good to decent mechanical properties, ductility, things like that. I would say 75% of our customers at this point are working with nylon 12 just because it does apply itself to so many different applications and use cases. So one use case here is manufacturing aids with this company here, the sound system. Manufacturing aids, jigs, fixtures, things like that. That's sort of our bread and butter. When it comes to applications, it's going to be something that, based on the customer need, they either rapidly produce it via 3D printing, or they go to the more traditional CNC where they're milling it out. And you can see from the geometries, I wouldn't even know how to mill those out in a more traditional way. With SLS 3D printing, you have complete control and flexibility of the design. You're not worried about support material or overhang or things like that. The only design considerations that we mention would be, well, what's your minimum feature size? What's your wall thickness? Things like that. Obviously, if these manufacturing aids are load bearing, you want to make sure that the walls are thick enough to not have any cracking or deformation where these parts may end up. And I believe at some point we will have links. Basically, every customer that we'll show today will have a support page or webinar related to their application. So definitely take a look through there if you feel like that application will apply to you a little bit more directly. Another great user story here. I have watched the YouTube video once or twice just showing his Ken's, I wouldn't call it struggles, but just there's always going to be the initial hump of starting your own business and trying to scale manufacturing. Obviously, Fuse does quite a good job at making it a little bit more approachable and easy, but there's obviously still going to be some trial and error to get things done the right way. So these items here, you might be able to tell, are for aftermarket AirPods cases, just trying to add a little bit of value in the charging stations and things like that. And with Fuse and the build area, you can see the full build area being filled up, 12.5 hours of printing, about 11 hours of, about 14 hours, of cooling. And with that, he's getting each part, probably under $1, $2, something like that. If he were to go the traditional injection molding route, at some point, he would have it more towards the injection molding side. From our experience, usually around the 5,000 to 10,000 unit mark. And if you're just starting out and you don't want to spend all that upfront cost to get, 5,000 units, and then you realize, well, maybe I need to redesign the part a little bit. Those kind of oh shoot moments, that's where you really want and kind of want the value of the Fuse, because there is no lock-in of a geometry. You can do however many different designs you want, all within the same build. Printer doesn't care. It's not going to change the cost. It's a fixed cost based off of just the total amount of sintered powder that you are utilizing. So again, we'll send you the YouTube link. Great watch. It's only 10 minutes. Watch it on 2 times speed. You can get done in 5 minutes. Next material is Nylon 11. So Nylon 11 is going to be our ductile material, high performance, high impact. So going back, Nylon 12 has an elongation at break of about 10 to 15%. Nylon 11, when printed in nitrogen, is about 40%. So this is going to be your bend not break material. So great for snap fit assemblies, clips, hinges, and then very big in the O&P industry, orthotics and prosthetics. Customer here pretty much speaks for that. You can see the amount of bending you can get in the top left. And with the diffuse ecosystem, you have the, as I said earlier, full control if you want patient-specific identification numbers, or obviously it's based off of foot scan data. So you can have patient-specific geometries, call it next day, for upwards of, could be 100 individual pieces, depending on the number of parts. something you couldn't do any other way. Nylon 12 glass filled. So this is one of our composite materials. So it is a base nylon 12 with the glass filled added in. I believe it's roughly 30% glass filled by volume and then 50% by weight. What that is going to do application wise is robust jigs, fixtures. These are the parts that you don't want to move. They're going to stay rigid, stay where you want them to be. Something like this would be threads, sockets where you need no surface sort of degradation over time. Very good for connectors, plugs, things like that, where you need super accurate pieces. This is where we generally push customers towards. So Broza, they are a automotive parts manufacturer, for lack of a better term. So they have a small fleet of Fusion Pluses, and some of the parts that you see here, they are actually going on cars. The BMW X7 is the specific car that is going on the clips on the bottom left. So again, with the number of parts that they're working with, the pattern pricing that they're working with, and the cost per part, and the number of fuses that they're running, they can keep up with demand, but also have the flexibility to change to a different part, change, minor design tweaks, things like that. They can be agile, but also cost competitive, and the lead time will be a lot shorter because you're not waiting for molds to get cut or whatever it may be. Next is Nylon 11 carbon fiber. So Nylon 11 CF, this is going to be our best material when it comes to tensile strength, the strength to weight ratio. It is a not particularly dense material, but it is very, very strong. So this is drawn in a lot of customers for either high impact equipment, really strong functional prototypes or actual end use parts. And it is the closest equivalent to a metal part, say like a aluminum housing or whatever it may be. Customer here is Tum Boring. So they are actually adding on some of the cutting devices, printing them in Nylon 11 CF, something that they initially did not expect. What they were doing is they were applying so much force, they were able to move their 15-ton container and did not see any breakage on the Nylon 11 CF parts. If someone told me that without the testing and the actual verification, I probably would have said that doesn't make sense. But obviously they found a way with the geometries and the orientation and the material to work out well. So definitely glad to see that these guys are doing well. And the part on the bottom left, I believe that is in our durable or tough material, and that is on our resin system. So just to show that obviously our customers are not just using SLS, it'll be a mix of both technologies. Nylon 12 tough. This is one of our newer materials. So this is sort of the middleman between Nylon 12 and Nylon 11. It has an elongation at break of roughly 25%-ish. This is something where snaps, ratchets, hinges, things like that. What we have found most recently is for customers that have been outsourcing parts via HP. So that is the MJF technology. This is basically call it a 1-to-1 for their normal Nylon 12, just differences in technology and things like that. This is going to be most representative of that. So for customers that have actual use cases from the Nylon 12 via MJF, this is our call it response to that. I love the material. I haven't had any major issues with parts. It has a similar sort of ease of use to the Nylon 12, but it also has better mechanical properties via ductility and things like that. So it will be a lot more impact resistant, and whether you're dropping it, throwing it, whatever, the Nylon 12 Tough can withstand those mechanical issues. So building momentum, great customer. They were actually in our office a few weeks ago shooting a webinar that may or may not be live now. They are doing, as you can see here, drones in Nylon 12, and they are also utilizing TPU 90A for some other components just to fill in the full assembly. And you can see based on the pictures here, a couple of different sizes, a couple of different geometries to work with. The lightweighting of the arms on the side, that's something you only really get done via SLS 3D printing. Because you have no support material, you can do basically whatever you want as long as it's thick enough to stay in one shape and hold off the mechanical loads and not shear. With the Nylon 12 Tough, it was just the best option for them. Could they have done Nylon 11 CF? Probably, but for their use case, the Nylon 12 Tough also fit in very, very well. Yeah, I think most parts, the body, some of the arms were 3D printed. We did leave the propellers themselves, more traditional methods, just the high RPMs we've seen not be the best. So we are obviously sticking to what we know will work perfectly, which is the body to keep it lightweight and sturdy. Last material, or second to last, I'm sorry, will be the Nylon 12 white powder. So it's essentially a Nylon 12 material, but the base color, instead of being gray, is going to be white. So there are two routes that customers do. Either they keep it white or they utilize a dyeing solution, dye bath. It's basically a little bit of heat, a little bit of substrate to put into the mixture. Takes all of 10 minutes, and then you can get a wide variety of colors. If you were to dye Nylon 12 gray, it's always going to be a more matted or muted version of whatever color you're looking to achieve. So, excuse me, the bright red and the bright blue would not be attainable on the Nylon 12 gray. So the Nylon 12 white is the basically only way to go. It also has similar levels of biocompatibility. So this could either be medical models, surgical guides, again, O&P if they want the white color. It's just a cleaner look, and our medical team was asking for it for years, and they're very happy to finally have access to it on a Fuse 1 Plus. This customer here, obviously not in the medical space per se, but they are producing these housings, covers in Nylon 12 white. In order for them to get the brightest white possible, they are utilizing a Fuse 1 Plus 30 watt and the inert gas via nitrogen. What that nitrogen will do is push out all the bad stuff, reduce oxidation, and have the powder and the end process and parts be a lot more white and obviously more appropriate for their use here to have look a little bit more professional and things like that. Obviously, what we don't want is the parts to yellow or not have that bright white look that they're looking for. TPU 90A, so this is going to be our flexible material. It does have an elongation at break of about 300%. So whether you're looking into wearables or custom grips, dampeners, cushions, whatever it is, it all sort of fits the bill. The beauty of the TPU 90A is you can have it based on the geometry be a solid block and very, very little elongation, or you can create your lattice structures to where it's extremely flexible and malleable. There are ways where you can create lattice structures based on input forces. You can have different lattice densities and directions, and that would give better output forces. Imagine shoe insoles, or maybe you're just trying to protect someone's head via collision for a motorcycle helmet, adding in custom foaming and things like that. That's where the TPU comes into play. And it does have the long-term skin, short-term mucosal contact for those types of applications, medical applications. So anywhere from healthcare to manufacturing to product design, TPU 90A has found its way in. And example here is Artist 3D. So they are doing end-use parts, skin safe. You can see some are just directly off of the printer, where it's just a basic blast. Some are vapor smoothed. So vapor smoothing is a separate process from the blast. The blast is mechanically abrading the parts. Vapor smoothing is chemically abrading the parts. So you'll see on the top left, the darkest part, the small one, that is vapor smooth. With this can be either based off of scanning someone's arm or just having set dimensions and they just choose whatever combination works best. Printer doesn't care as long as it takes in the mesh file, it'll print it no problem. And you get the very durable, very tear resistant TPU to last a very long time and be obviously quicker to produce, and in that way cheaper for the customer. Legacy Effects, another great user. So they utilize both our system, the Fusone Plus, and HP via the MJF systems to do a wide variety of parts for the entertainment industry. So you can see in the top left, Alien Romulus. They've done stuff for Marvel and some other kind of large movie names and things like that. Some stuff they can share, some stuff that they can't. Definitely take a look at their website and see what you recognize. With the TPU and the Nylon 12, it's just a good mix of, if you need a rigid hand and then some more articulating fingers, that's where you use the TPU. So with that, they are blending a couple of different materials together, a couple of different technologies to get a wide range of solutions for them. And with how quickly they're producing parts and how many different parts that they have, I don't think there's any other way for them to get what they need. Okay. So I went through over all of the materials themselves and certain applications use cases. For you specifically, you may not have the sort of North Star without talking to someone like myself. So what Formlabs has created is a SLS material printability chart. What we are doing is creating basically a standard of, well, if you're looking for the best print speed, if you're looking for either dimensional accuracy, whatever, we do have a fair, good, best table. So you can, relatively quickly figure out which material is best for you. Let me actually get rid of my video here so you can see the bottom. So you can see most parts, like dimensional accuracy, you're looking at the Nylon 12 and Nylon 12 Tough. High aspect ratios, same kind of deal. When we say fair, good, best, we can still get fast Nylon 12 glass filled, or we could get fine feature resolution on Nylon 11 CF. What it may require is just a secondary step to look at either the geometry or even some settings here and there to just take that one-time check, adjust it, and then have it be a little bit more suited for your specific geometry, machine, and material, and we can improve that a little bit. We're just trying to create a better understanding of the initial expectations of the material so customers can make the best decision going forward and understand the natural just pros and cons of each material. So for an example here, surface finish. Obviously, surface finish is going to be the first aspect that everyone will understand. Nylon 12 is going to be one of the best when it comes to surface roughness and the feel of the part. You can also polish the material as well, but what we're staying here with the best, it's going to be one of the smoothest materials and repeatable from print to print, no matter where you are on the build area. And then minor print artifacts, may show up very, very rarely, but it's usually due to something else, not correlated to the material itself. Nylon 12 white would be considered good. This is something where we would more strongly push a polishing process as opposed to keeping it just naturally off of the printer itself. That polish would, in some ways, move it from a good to best, but we're assuming everything is just directly off of the printer, no special cases from there. And then fair would be the TPU 90A. TPU 90A is always going to be a little bit fuzzy, a little bit rough, depending on the curvature of your part. So with that, we just need to set a general understanding of what to expect. Obviously, customers can vapor smooth parts. They can't blast it just because the TPU will just bounce the media off. It's just the nature of the material. But just something like this, there are ways to work around it. We want to make sure that customers know what they are getting themselves into. And as customers like yourself want to learn more about the materials and your specific geometry, obviously you go to someone like myself or a sales rep, and we can run through the specific custom part analysis, get it printed so you can see firsthand what those parts will end up. Another factor here is fine feature resolution. So this is specifically for small text or embossing or whatever it is. Nylon 12 tough will be basically the best when it comes to small text and things like that. Items like Nylon 12 glass filled, they will not do particularly well. So just keep that in mind. We will have design guidelines listed, and you'll just need to have a slight revision if you printed it in Nylon 12 tough, up the text by maybe 10-15%, and then it'll work well for other materials. This chart here is for the mechanical properties as well as absorption rates and temperature resistance. So pretty straightforward there. I'll go over two of them. Tensile strength. So this is the amount of stress the material can withstand while it's being pulled, before breaking. Nylon 11 CF is going to be the best by far. Just for the Nylon 11 CF, we need to recognize that it's going to be in the XY plane, and there will be printing in certain orientations. On the low side, obviously TPU, because it elongates so much, it's not going to require a ton of force before it actually starts to move. And then you can see the scale in the middle. Nylon 12 gray will be one of the best as well. Nylon 12 tough is only good because it has a little bit more elongation and flex to it. Speaking of elongation, you can see here the breakdown. 11 CF and 1112 glass field, they're going to be your rigid, high strength materials. Obviously, once they start to bend, they will break. If you do need some bend but not break usage for your parts, that's where you look into the Nylon 12 tough or Nylon 11, because it will have that spring back effect. If you want to know more about each material, we do have technical data sheets for every single powder. That's based off of standard ASTM testing, and that'll give you sort of the best initial comparison if you're trying to, well, how does it compare to Delrin or injection molded ABS? TDS sheets are the way to go. So a couple more use cases here. This is just to show that our customers are utilizing both SLA and SLS together. I'm sure all of you know Ford Motor Company. So they are doing some rapid prototyping for some housings, both in the gasket section, whatever you want to call it, and some other housings in the car interior towards the steering wheel in the middle. And one of those things where you don't want to cut a tool to produce these pieces if you're still going through the design iteration process. They can do these in transparent materials, in high temperature materials. If they're going under the hood, they can choose whatever they want because they have so many materials available on SLA. And then once they find the right geometry and the basic application needs, then they can choose a material on SLS and produce them very, very quickly at high quantities. Air ion, very cool application. So this is for female fighter pilots. So this is a bladder system. Obviously, they need to use the restroom, and this is a system that they can use to relieve themselves. And that's a mixture of, skin safe TPU, and then the Nylon 12 is for the housing, and then it is working with the controller as well. We do have a webinar that goes through the design process, some of the design considerations, and like long-term usage of the items. So again, we'll link it. Take a look. Really cool story here. Deutsche Bahn, they are producing manufacturing aids. So they are not going to be the end-use parts themselves, but they are there to streamline their manufacturing or cutting or assembly processes, just custom pieces that they can pop into place and save their workers a ton of time from having to measure twice. They can just pop in the piece, cut once, and move on to the next one. Okay, perfect. We are 43 minutes past the hour. What we can go through is the Q&A. I see a couple of them. All right, I'm going just to top to bottom, and then we'll see how many we get through. While I am going through the questions, there should be a couple more polls popping up on your screen. Just 2 more questions, and then if you take a second, please answer, and then we'll go through your questions. First question is, how would you color the finished SLS parts cost effectively? And does this work with the natural or the white material? So from the costing perspective, most of the cost that we have from customers comes from the actual labor. So there are some die units where you can only fit half a dozen parts. There are others where they are much larger tubs where you can fit 15, 20 parts, something like that. And sort of the economies there where based on your need, there's going to be the best solution between how many changeovers versus like how much downtime and things like that. The substrates and the dyes used, they're not particularly expensive. I wouldn't say that is the limiting factor. It's just the amount of time put in to produce each part afterwards. And then, does this work better with the natural or the white material? If you are dyeing them black, you can use both the gray and the white. If you're going for bright yellow, pink, blue, then you would utilize the Nylon 12 white. Is it possible to get a part out of a 3D printer which is FDA certified? So yes, we do have a full regulatory and compliance team here at Formlabs. We do have a decent amount of customers that are going through like the 510K approval process. Obviously, the printers and the materials are just one part of the entire workflow to get that situated. Formlabs, we do our best to provide you with all of the like manufacturing certifications, all of the tracking of like lot numbers, COAs, and things like that. So we're not going to be a hurdle to jump. So again, we have done it in the past. Definitely talk to us, and we can make sure you're going on the right path and can get there as quickly as possible without us being a hindrance. We have a question on how do you optimize printing to get a constant 70-30 refresh rate? I find myself lacking a recycled powder constantly? Yep. So it's a good question, and something that some customers, if the geometries are just very open, very low utilization of cinder powder, that is sort of just what happens. I know what we do here sometimes is, obviously we have customers come to the office. We'll have our custom pieces that will take up, say, 3% of the build, and then we'll have other pieces, giveaway pieces, trinkets, whatever it is, to help fill up the parts that way. That's sort of when you have the low pack density and you need to go higher. When you have a higher pack density and you are utilizing, say, 40-50% cinder powder each time, you will run out of used powder quickly. So what we've done in the past is actually pre-age some powder. So like if you're printing Monday to Friday, what you can do is run an aged powder build over the weekend, to where you'll take new powder, pop it into the hopper, and then your build is basically just like a single part at the very, very top of your build space. And so it'll preheat it, it'll go through a cycle, and you'll just build up used powder that way. That's been sort of the best way to combat that. It's either that, or you try and play around with like a different refresh rate, but that turns into a bigger deal as well. So I would just run an aged powder build as needed. You'll get 4 or 5 kilos worth of the used powder that way. Is there an app that can be used to make STL files for SLS 3D printing? So yeah, with the files themselves, you have your native CAD software. Think of SolidWorks, Fusion 360, Rhino, CATIA, whatever you're using. Preform does take a few of those native CAD files, like .prts and sometimes step files and things like that. Most commonly, what users will do is just export their native CAD file as a STL file or OBJ file, a mesh file, and then our Preform software does the rest. So again, that's sort of the timeline of things. As long as you have your SolidWorks or whatever, you can just export it as the STL, and then Preform will be able to handle it. Good question. How long does it take to change the material from white to black and vice versa? So for materials of the same base, so Nylon 12 and Nylon 12 glass filled, I am axing out Nylon 12 white here. It's about an hour to go from Nylon 12 to Nylon 12 glass filled, because you're basically at the same melting temperature and process conditions. If it's Nylon 12 to, say, a TPU, TPU melts at 130 degrees Celsius. And so what we will require there is more like a 3 to 4 hour changeover, because we want to ensure that every surface is going to be clean. Because worst case is you're running a TPU build, or sorry, a Nylon 12 build that's heating up to 180, and you have leftover TPU that melts at 130 C. Well, it's going to melt, then burn, then smoke, and cause some bad things. So absolute worst case is about a half day. If you know you're going to be producing a lot of different materials and parts and things like that, the printer isn't all that bad to clean out. The tricky part is going to be the sift, because you have so many internal channels and hoppers and things like that. So I would suggest either a second sift, or you can use one sift and one depowdering kit, which was that manual version of the sift. That'll save you a lot of time in the long run. Can these parts be cleaned in an autoclave? Yep, they can handle that. The gamma, the standard methods, they can handle that, and we do have some sterilization autoclave data that we can send you as well. SLS photopolymerization. So yeah, just to reiterate the SLA versus SLS. So SLA, we're using a liquid resin. We are then using UV light to cure them. It's essentially a chemical bond. With SLS, we are preheating the powder and then using a 30-watt laser to add in just enough energy in specific areas to melt, sinter, and then harden the parts. That is more of a chemical bond. So they are utilizing traditional thermoplastics in SLS, and SLA, they are utilizing thermosets. Basically, thermosets, once you cure it, you can't melt it and have it cure again. With SLS parts, you can print it, heat it up a little bit, add in whatever parts, and then it'll set again. So just some core differences there. Is there a water absorption or heat rating on these materials? Yes. So the technical data sheet will have solvent compatibility table. So we're basically submerging a cube in whatever solvent for 24 hours, and we add a % weight gain. And then there is a HDT value, whether it's under load or no load. So definitely look at the TDS sheets and they'll answer your question. Yep. Question. Powder sending process. So they are thermoplastics, no curing process. You are absolutely correct. There's no curing in SLS. It's just all of the preheating, sintering with the laser, and then it is a passive cooling process. What is the difference between the Fuse 1 and the Fuse 1 Plus? The Fuse 1 utilizes a 10-watt laser, and the Fuse 1 Plus utilizes a 30-watt laser, and it does have a inert gas hookup, most commonly using nitrogen. So when it comes to future-proofing for new materials that we may produce, the Fuse 1 Plus is the way to go. And if you are looking for much quicker prints, the Fuse 1 Plus is also the way to go, because the 30-watt laser will allow us to obviously laze faster, and it's less dwell time per layer, and overall just a more streamlined process. Can some materials be printed after another material without cleaning the printer? Short answer is no. There are going to be other areas like some of the recoders and some other little hidden areas that would need to get cleaned out beforehand. We have a question, looks like from a current customer. Will the user experience be improved with the new 10-kilo bags, more spills, contamination, things like that? Yep. I mean, I've had a similar, call it spill, early on. What we ended up doing was basically 3D printing a little, call it a clamp, to better funnel the powder. And what that would do is have it be more targeted, as opposed to less reliant on however you cut the bag that way. So we could definitely follow up offline and see what we can do for you there. Will we have a PowerPoint of this presentation? I don't know if we'll have a PowerPoint, but we'll definitely release the webinar itself. That will have the recording and everything. You can check out the slides that way. I will say most of the content here is found some form or another via a support page or application study, or via a separate webinar that goes through that customer in a lot more detail. Does the powder quality degrade when stored for a long time? Nope. Shelf life is generally about 2 years. The only time we would ask for special handling is if there is a ton of humidity in your space. From there, we would just recommend a dry cabinet with some like silica dry packs and things like that. And that would be more than enough to keep it clean and ready to go. Do we offer any special prices for educational institutions? Yep. We did have month or two ago, a updated EDU discount. I believe it's 10% off and maybe a free open material mode for a Form 4. I'm not the guy to quote or sell you things, so definitely go to our contact sales and they can get you the latest pricing and discounts for our EDU customers. Do you help make STL files? So from the Formlabs side, we wouldn't have the ability to contract out like I need to make this specific jig or things like that. We're here for more of you come to us with an STL file and you want it better suited for 3D printing, or you want to find the right material, cost analysis, things like that. We can definitely send you to other companies or resources online that can help produce the STL files. And then once you have the STL file you want to print, that's when you come to us. Have there been any additional improvements in terms of safety, printing process, curing, cleaning, ventilation? Yep, we're always cognizant of where our printers are going, how they're being utilized, and what safety considerations our customers need to be aware of. Obviously, with powder, the number one sort of addition we had was the glove box in the sift. The glove box is technically optional. What that will do is prevent basically any excess powder from going out. We do have negative pressure that sucks in most of the excess powder, but that glove box there is just an extra level of safety, just for the extra concerned customers for where it needs to be. We do have dust particulate studies. They were done in our custom print farms, in our engineering spaces, and we were well below the OSHA limits. So like at a minimum, we'll wear the nitrile gloves, and then it's more personal preference. If you want to wear the N95 mask, like if I have a customer coming in for a tour and they want to do a quick little demo and sift some parts, I wouldn't recommend wearing a mask. But if they're in there for a full day running through it, parts are being sifted, printers are running, my personal preference would be to then wear a mask. Can items be printed using silicone? Yes, so we do have a true silicone, a silicone 40A that can be printed on our Form 4. Yeah, that's basically it. We can do it. Shelf life, how does the quality when the material is recycled a number of times, how does that affect the powder? So we have a set refresh rate for each material. Nylon 12, it is 30%. So every single job, you are utilizing 30% new powder and 70% used powder. What this will allow for is continuous quality all the way through, no matter what. There will be some portion of the powder that has gone through a cycle 10, 15, 20 times, but it's such a small amount and it's distributed, mixed in with everything else, you won't see any quality differences. This is just based off of the data and the tests that we ran when coming up with the material, a few years back. There are customers that will utilize different refresh rates, either to just get rid of more new powder or to cheat a little bit and use less new powder. Just note that roughly between 5 and 10 cycles, if you are utilizing a lower refresh rate, you will see a higher rate of quality defects, either usually like birch bark or orange peel or things like that. Mike, hi Mike. Are there any benefits for nitrogen in other materials? So just to make it clear, the only materials that require nitrogen are going to be nylon 11, nylon 11 CF, and then nylon 12 white, if you want to have them be as white as possible. If you are dyeing your parts afterwards, you don't need to have nitrogen for nylon 12 white. It's only there if you want the whitest parts possible, and that's all you're doing. But like TPU, nylon 12 tough, glass filled, has no effect on those materials. We would not recommend it. it would be a waste of time. And then what are the NDA considerations for sending your models for test prints? We have a legal team. Either you send us your NDA or we can send you a mutual NDA, and that would protect most customers. Obviously, we are not ITAR certified in our print farm here, so we do have plenty of DoD and government customers where they won't send us their actual CAD data. They'll send us something off of like Thingiverse or whatever online that is somewhat indicative of what they want to print, and we can work at it that way. Okay, I believe we are obviously over time. I went through pretty much every question that I saw. Anything else that will pop up, definitely reach out to us. For every attendee here, they will get a free sample SLS in whatever material you want to see, and then obviously contact us directly or your authorized reseller if you want to go through your specific application, your specific needs to see, well, is this cost effective? Will this work? How are other ways of manufacturing this? This is what I'm here for. That's what I'm happy to do. That's what I love talking about. So I want to thank you all for your time. That's all I got. Enjoy the rest of your day and hope to hear from you soon. Bye all.